Over the course of the last 2 winters, we have been experimenting with ice, exploring the structural potential and the constraints of the material. We know ice works well in compression. If a hanging catenary is solidified and flipped around, the resulting structure is purely compressive. But what if it gets too big to be flipped around? Combined with a material of high tensile strength, shapes that work both in tension and compression, like hyperbolic paraboloids, can be designed. But after building an even bigger structure, we got aware of the constraints of these surfaces, because ice is ephemeral in its nature. In tension, the thin ice layer starts to crack and to deform, and the changing temperatures make it creep and melt. It finally led us to the question, can we find a structural principle that takes the dynamic behavior of ice into account? Learning from these experiments, we aimed for a higher redundancy towards the deformation process of ice. Our new structure consists of 2 interconnected systems. An upper textile approaches a soap film geometry and takes on the tension at the moment it is stretched in between the defined boundary conditions. This double-curved surface is dissected into a cutting pattern, with its cutting lines along the inner tensile stresses. When sewed back together, the stress lines get reinforced. A second layer is suspended into the upper one, approaching the geometry of compression arches. A series of thrust lines connect with the upper textile, adding structural depth to the surface. A foldable wooden structure provides the framework for the ice shell. The 2 layers of textile are 3-dimensionally seamed and pre-assembled in a controlled environment. The double-layer fabric creates an overlay of two structural systems, whose advantages are activated one after another. During the icing process, the upper surface takes on more and more tension as the ice grows on the mesh. During that process, the suspended textile freezes into a folded shell structure, and when the false work is removed, the shell is activated and the iced arches absorb the compression forces. It is especially the three-dimensional interconnection of the textile and the resulting structural depth that, together with the double curvature, enable the construction of an efficient and spatial shell structure without the use of any formwork.